Hey physics, this is Mr. Hausman. We're going to take a look at number 5, the Peregrine Falcon dive bomb. So Peregrine falcons, their physics of their flight is so cool. So picture a bird, flying along and it sees a prey. Maybe a bunny rabbit, a little mouse in the field, and what it does is it tucks its wings and it basically dive bombs. But for the first 10 seconds, it accelerates, and after that, what we find out is that the bird reaches a terminal velocity. Terminal velocity is a kind of advanced terminal, velocity, means that the air resistance has equaled out with the force of gravity, but what we know is that if it's constant, that the acceleration is 0. In fact, as soon as we know the acceleration is 0, then we will only use equations for constant velocity. And we know that the v of this bird is very fast, 97.2 meters per second. And the height of the bird when it reaches that terminal velocity is 100 meters up. You could call it delta y if you want, but basically it is going to drop 100 meters. But because it's not an accelerated motion problem, you should be looking at formulas only on the left side of your card. And what we see is v is equal to delta x over t, or you could use distance over time. And we know our velocity is 97.2 meters per second. We know the bird travels 100 meters, and the question is how much time? And the time is going to be equal to 100 meters divided by the velocity, 97.2 meters per second. How did I do that? I multiplied both sides by t, and I divided both sides by 97.2, and t is alone on the left, and we have 100 over 97.2, and most of you know that that's going to be just a little over 1, because 100 is a little bit bigger than 97, and 100 divided by 97.2 is 1.02 seconds. So kind of a tricky, easy problem, a constant velocity problem that's mixed in with a bunch of accelerated motion problems. Why? So you don't get into a rut.